This is problem on first law of thermodynamics. I'm going to read this first. An object whose mass is 100 pounds undergoes a decrease in its kinetic energy of 500 feet times pound force owing to the action of a resultant force. Initially, the velocity is 50 feet per second. There is no change in elevation and there are no other interactions between the object and its surroundings. Determine the final velocity in feet per second. So this is just a summary of main things that we've got so far. Given mass, given change in kinetic energy. Actually, it's negative change in kinetic energy because it's a decrease. So it's going to be minus. And then initial velocity is given. And what we need to find is the final velocity. So first we need to remember what the formula for kinetic energy is. And the formula for kinetic energy is delta Ke equals to 1/2 times mass times the difference of squares between the final velocity and the initial velocity. So we can start. So delta Ke is going to be negative because it's a decrease. As it says here, it's a decrease and not an increase in velocity. So basically, the object is slowing down. And we need to find the final velocity, Vf. So we've got, for delta Ke, we've got minus 500 feet times pound force equals 1/2. Mass is 100 pounds, so we put 100 pounds here, times Vf square. Vf is what we're going to have to find, so we're just going to leave it like that, minus, it's a 50 feet per second square, so 50 feet per second square. Okay, first of all, we're going to have to change 500 feet times pound force into 500 feet times pounds times foot over second square, because so we have consistent units through the whole equation. So what we're going to do is we're going to multiply this by the conversion factor. So we're going to have minus 500 feet times pound force. We're going to multiply it by 32.2 pounds times foot per second square, and that is for this is how much 1 pound force is in just pounds. Okay, so this will cancel, and next thing here we're just gonna do our calculation. 100 divided by 2 is 50, so here we got 50 pounds. Then we're going to keep our parentheses for now. Vf square minus 50 square is going to give us 2,500 feet square per second square. Okay, so next we're going to multiply the negative 500 by 32.2, which is going to give us minus 16,100. And we're left with pound times foot square divided by second square. And on the other side, we have 50 pounds times Vf squared minus 2,500 pounds times foot squared divided by, I'm sorry, it's actually going to be not 2,500. I forgot to multiply it. It's actually going to be 125,000. So I'm going to switch it back. So we're going to have 125,000 pounds times foot square divided by second square. So that's better. So now once we move the 125,000 over to the second side, to the other side, we're going to have 108,900 and it's going to be pounds times feet squared divided by second square. And on the opposite side, we've got 50 pounds times VF squared. So now we're going to have to isolate VF squared. So we're going to divide both sides by 50 pounds. So when we divide both sides by 50 pounds, we get 2178 feet squared divided by second squared. So now we're going to take square root of both sides. So in this case, our VF is 46.67 feet per second. And this is our answer.